Hi again. We're going to be working on problem 6 from the practice problems for module 6. And this one says that phosgene, which is COCl2, was once used as a chemical weapon in war. When humans breathe in the gas, it reacts with the water in their lungs in the following way, and it gives the chemical equation. The product HCl burns the lining in the lungs, making them unable to function. Thus, by breathing in phosgene, a person will eventually suffocate. Assuming that 10.0 grams of HCl in the lungs is deadly, how many grams of phosgene would a person need to breathe in order to die? Bit morbid of a problem here. But we're given a chemical equation, so we don't need to worry about coming up with anything and balancing anything. That's a fortunate thing. But we want to start with 10 grams of HCl, and we want to get 2 grams of COCl2. The problem here is we can't go directly from grams to grams of another substance. We're going to have to go from grams of HCl to moles of HCl, and then we'll use the chemical equation to relate that to moles of COCl2, and then we'll get to go back up to grams of COCl2. So that's going to be our process here. It's kind of a 3-step process with 1, 2, and 3. And so let's go ahead and get started. So in order to convert from grams to moles, we're going to need to know the relationship between grams and moles of HCl. And that is given on the periodic table. We have a very helpful tool for us to use, and it's given underneath the symbol for the element. Each element has its own atomic mass, and that's what we're going to be using. Now, HCl is a combination of 2 different elements, hydrogen and chloride. So we need to add together 2 different atomic masses to get the whole atomic mass of HCl. So we are going to need however many H's are in the molecule and however many Cl's or chlorines are in the molecule. Fortunately, there's only 1 of each. We don't have any subscript numbers here, so it's just 1 of each. And if we consult our periodic table, we will find that H has 1.01, and that's going to be grams per mole. And then Cl is going to be 35.5 grams per mole. And so in total, our atomic mass that we're dealing with for HCl is 36.5. Technically 36.51, but because of significant figures, we won't count that one. So 36.5 grams per mole. So now we know that relationship. So let's go ahead and convert. So we're assuming there's 10.0 grams of HCl. So we're going to start out with grams. And we know we're going to have grams on the bottom because that has to cancel out. And so we just need to look at our relationship. So there's 36.5 grams for every mole of HCl. And we can go ahead and convert this via a calculator. 10.0 divided by 36.5. We're going to get 0.274 moles HCl. So what I will do is I'm going to jot this down at the bottom. You can really jot it down anywhere. I just want it to be available for us at a later time, so I can go ahead and erase this. And I'm going to go ahead and erase the work that we have up here so that we can work on the next part. I'd suggest if you're doing this with pencil and paper, you don't erase and you just keep it so that you can look back and check your work later. So, we know how many moles we have. Now we can go from our second step, which was moles to moles. So, we're going to go ahead and write down our 0.274 moles of HCl. Put that over 1. We know we're going to have moles HCl on the bottom because that's going to cancel out. I'm sorry, that's not H. That is HCl. What we're going to have on top, what we're going to, that's what we need to write down, and that's COCl2. And this is also going to be moles. And then we need to look at our equation to figure out the relationship. So for every 2 HCl molecules, or every 2 moles of HCl, we're going to have 1 mole of COCl2. So it's just a 2-to-1 relationship. Make sure the 2 goes with the HCl. And then we can figure this out with a calculator as well. So we'll just divide that answer, 0.274 by 2. And we should get, I'm just going to go ahead and write this down over here right off the bat. COCl2. That's going to be 0.137 moles of COCl2. So we can erase this part again because we have our moles of COCl2. And now, if you remember the diagram from before, we went from grams to moles. We went from moles to moles. Now we have moles COCl2. We have to get back up to grams to figure out how many grams of COCl2 we would need. Not that we're trying to kill anyone, but that would work in this chemical equation. I don't advise trying to use this. Okay, so we have our conversion, but we need to know how many, well, I can already put up here that we're going to be going to grams, COCl2. What we don't know right now is what the relationship is between 1 mole of COCl2 and grams COCl. To do that, we need to consult our periodic table again and add up those atomic masses. So there's carbon, there's oxygen, and there's 2 Cl's. And so if we look at carbon, that's 12.0 grams per mole. If we look at oxygen, it's going to be 16.0 grams per mole. And then Cl again, which we had before, was 35.5 grams per mole. And we know this was multiplied by 2, so we can go ahead and factor that in. So if we add all these up, we're adding 12 plus 16 plus 35.5, but that was multiplied by 2. We have a grand total of 99.0 grams per mole, and that's COCl2. And so we can go ahead and put this up here, 99.0 grams COCl2, and if we multiply 0.137 times 99.0, we'll get 13.563. So this all equaled 13.563 grams COCl2. And if we account for our significant figures, we can use 3. It's our minimum number So we're looking at 13.6 grams CoCl2. So that's it. There were a number of steps there, but we managed to get from grams to moles to moles to grams. And all in all, even though it took a little bit of time and a few steps, it wasn't really that difficult.